Hello everyone, my name is Ankush. I completed my master's from IIT Ropar, and here I am working as a senior OCP faculty in Orchids International School. So today I am going to present here a video series. The objective is that to enhance your score so that you all can score above 90%. So topic for today's discussion is electricity. So here we are going to discuss about the previous year questions, and the distribution of the question is like that. We are going to consider all questions like from the MCQs till 5-mark questions, 1 mark, 2 mark, 3 mark, 4 mark and 5 mark questions. So first of all, I'll start with the very basic questions, that is the MCQ which was asked in the previous year, the question papers. So the first question I'm having here is, the first question that is asked in 2024 1-mark question, that is from the power, or you can say the heat produced. So the question is that an electric iron of resistance 20 ohm draws a current of 5 ampere and the heat developed in the iron for 30 seconds. So the question, how to proceed that question, obviously this question is about the heat produced. So the formula according to Joule's law of heating, H is equal to, H means heat, is equal to I square R into T. So H equal to I square R into T. So I value is already given in the question, 5 square. Resistance already given in the question, that is 20, and time, that is 30 seconds. And if you solve this, you will get this, the total, that is equal to how much? 15,000 and joule. Why joule? Because we have taken here all the units are in SI units. So the joule is the unit of heat produced. So answer for this question is the first 15,000 joules. Apart from that, let's have some extra discussion about this particular topic. Sometimes they ask questions also, because we can calculate heat by using the other formulas also. H is equal to V square by R into T, and can be written as equal to V into I into T. So these are the other formulas that we can apply to calculate the heat produced. Why I'm telling? Because sometime in MCQs they will provide 4 options, and in this they will ask which of the following formula is not correct for calculation of the heat. So you should know all the 3 formulas that is written over there. So this is our first question. Answer for this question is A, 15,000 joules. Now let's move on to the second question. The second question we are having is, the second question, that is again from 2024 1-mark question, and this question based upon the combination of the resistors. So first of all, let's have a basic discussion about the combination of the resistors. So the combination of resistor, we already know that we are having the basic series, parallel and the hybrid combination. So in series combination, if we have to calculate the equivalent resistance, so R equivalent is equal to simply the sum of resistances which we are connecting in the series. In parallel, the equivalent resistance formula is 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3, means the reciprocal of the parallel combination of resistors is equal to the sum of reciprocal of each resistor, whatever number of resistors we are having. So in this question, you have to make sure after calculating this value, you have to take the reciprocal, which is a common mistake generally student commit. We should not do that mistake. Achha, in parallel also, we can calculate the resistance, especially this question is MCQ, so in this only 2 resistors are given. So direct formula for that is, in parallel combination, when 2 resistors are connected, then the Rp is equal to product of resistances divided by sum of resistances. This formula directly we can use instead of using this formula, but you need to take care of one thing, that this formula is applicable only for 2 resistors. So in my question, what are the resistance 1 and 3 ohm that is connected in parallel? So my overall resistance will be equal to what? 3 into 1 upon 3 plus 1, that is 4. So I can say 3 by 4 ohm, that is the overall resistance for the parallel combination. Now current, how much current this resistor, this circuit is drawing? This is the one resistor, this is the second resistor, both are in parallel, and they are drawing how much current from the battery, that is equal to 1 ampere, and we have to find out how much current is going into the each arm, that is 1 ohm, that is 3 ohm. So from there, one thing is very much clear, most of the current will go through the low resistance path, means maximum current will flow through the 1 ohm and less amount of current will flow through the 3 ohm resistor. So we got the value of overall resistance. So what is the potential? So V is equal to how much? I into R. So what is the current? I, 1, and resistance is 3 by 4. That means the voltage we have applied here is 3 by 4 volt. So the voltage we have applied there is 3 by 4 volt, and we know in parallel voltage will remain same. So now in the question they are asking that how much current will flow through 3 ohm resistor. So 3 ohm resistor is what? This is the 3 ohm resistor, apply Ohm's law. So we know that V3 is equal to I3 into R3. We are interested in the value of current. So I3 will be equal to what? V3 by R3. And by solving this, what we will get? 3 by 4 upon 3. 3 by 4 upon 3, I3 value will get as 1 by 4. So answer for this is option number D, that is 0.25 ampere. So this is how we can get the answer for this particular question. But as we know, this question is of MCQ question. MCQ questions are very simple and straightforward. We should do that in a straightforward manner. So here we can see that we have done a lot of calculation. If you're good in calculation, you can quickly get the answer. But there is another way to solve this question also. That also we will discuss here. So the second method, that we can use the method of the ratios. For example, we know Ohm's law equal to what? V equal to I into R. And we know that in parallel voltage will remain constant. So I can say the product of this will be constant. So from there I can say that I is inversely proportional to resistance. So in my question, resistance of two resistors is given. Means I can find the ratio of the resistance. Why I am finding the ratio? Because from this relation I can say that I1 upon I2 is equal to, as relation is inverse. So I1 by I2 will be equal to R2 by R1. So that is equal to what? R2 by R1. And in my question, what is R2 value? 3. What is R1 value? 1. So here we can see that the ratio of I1 by I2 is 3:1. 3:1. So now I am interested in the value of I2. So by the method of ratios, we can find out. The proportion of I2 is how much? 1 upon. The sum of ratios 3 plus 1 is 4, multiply by total current. How much total current is flowing? That is 1. So we got the value 1 by 4 ampere. So we got the value of I2 is how much? 1 by 4 ampere. And if they ask about I1, then obviously 1 minus 1 by 4, 0.75 ampere. For my question, answer is 0.25 ampere. So this is how we can solve this question, by simply using the method of ratios also, instead of using the standard method. So this question is done. Now few extra points I want to highlight over there regarding the combination of resistors. The one, we know that in series combination, equivalent resistance is sum of all resistors. Sum of all resistors. Now if in series, if all resistors are having equal resistance, then we should keep in mind the overall resistance R equivalent is equal to N times of R. When all resistors are having equal resistance. So number of resistors multiply by the resistance of each resistor. Second, in parallel, we know that 1 by Rp is equal to what? The summation of reciprocal of each resistor. So in this case also, if all resistors are equal, then the overall resistance Rp means the equivalent resistance of n resistor having the equal resistance, that can be written as resistance of each resistor divided by N. So this is the another formula we can keep in mind for MCQs. Another formula is, if we are having only two resistors which are unequal, then the product of resistors divided by sum of resistances, that we can use. This is the key points we can keep in mind for the combination of resistors. Another thing, we know that in series current will remain same. But if the resistor we are connecting, all resistors are equal, then voltage will divide equally. In parallel, we know that current will divide, potential difference will remain same. So if all resistors are having equal resistance, then the current will also divide equally. For example, 10 ampere current is going through 10 equal resistor, then it will get divided into 10 equal parts, that is 1 ampere, 1 ampere, 1 ampere. So these are the few points you should keep in mind that will help you in tackling the these kind of MCQ problems which are relevant to the combination of resistances. Now the next question we are having is, this is another question that is also based upon the series and parallel combination. Here you can see we are having different circuits. Here we are having, first is a parallel combination. This is, we are having a hybrid combination, and we are having another parallel combination. So in this question, what they are asking, now we can use the previous concept which is discussed in the previous question, that consider the following combination of resistor. This question is asked in 2024. We have to find out the combination having the equivalent resistance now 1 ohm. We have to find out of the 4 combination, which combination will produce 1 ohm resistance. Now we can simply see that the first combination, we know that parallel combination resistances are what? equal. And if the resistances are equal, then we know that in parallel combination, the equivalent resistance of this circuit will be equal to resistance Rp1 is equal to what? Each resistor divided total number of resistances. We got 1 ohm. So means what? 1 is the required answer. Now in option we can see that the option in which 1 is not available, we can eliminate. This option can be eliminated, right? Second, 3 resistors connected in parallel. So in this case also we are getting how much resistance? 3 upon 3. 3 is a resistance of each resistor divided by total number of resistors. We got how much? 1 ohm resistance in this case. So this is also our answer. So now option in which 2 is not available, we can eliminate. First option 2 is not available means this is not our answer. In option number C, 1 and 2 is there. In option number D, 1 and 2 is there. So we have to check for the third also. So third resistor we are having, we know that in series, the equivalent resistance is what? Sum of individual resistor. 4 plus 2 how much? 6. And here is also how much? 3 plus 3 is what? 6. And when two resistors now 6 ohm connected in parallel, then the overall resistance of this circuit will be equal to each resistance 6 divided by total number of resistors 2. So this will give us 3 ohm. But we are interested in 1 ohm resistance. So therefore option number 3 is not the correct answer. So option number 3 is available in this answer. This is also not our answer. So the correct answer is C. We don't need to check option number 4. We got the answer, that is 1 and 2. And by the way, if you check option number 4 also, that will give you what? 0.5, 0.5. 0.5 half is how much? 0.25 ohm. But we are interested in what? 1 ohm. So the final answer we are having is what? C option. That is our correct answer. So here we use that logic. If equal resistors are connected in parallel, then the overall resistance of the combination will be equal to resistance of each resistor divided total number of resistors. And if we are adding in the resistor in C, keeping resistor equal resistances in series, then the overall resistance is simply number of resistors multiplied by resistance of each resistor. So I hope you understood this problem. So let's move on to the next question. So next question, that is also that is from 2023. That is a 1 mark problem. Now this question is based upon the lab apparatuses. Right, we do the experiments in the labs also, but we should know certain basic things about those apparatus. So this question is based upon the voltmeter, and the question says that in the following diagram, the position of the needle is shown on the scale of the voltmeter. The least count of the voltmeter, we have to find out the least count of the voltmeter, number 1. And the second thing, we have to find the reading. What is the value of this particular reading? That we have to find out. Second thing, we have to find out the least count. So these things you should know, because when we do these experiments in lab, then we generally discuss about the least count. Least count simply means the least value that apparatus can measure. The minimum value that any instrument that can measure is called as least count. For example, we use scale. Right. In geometry box, we are having scale. So we know that the least count of that geometry box, that scale, that can measure is how much? That is 1 mm. Because 1 centimeter is divided into 10 equal parts, the minimum length that scale can measure is 1 mm. So 1 mm is the least count of scale. In the similar manner, the voltmeter can measure what is the least value that it can measure. It can measure, this is the least value, minimum value that voltmeter can measure. So this value is our least count. So first thing we have to find out that. Now if you focus on this, the voltmeter, so the reading of the voltmeter is how much? Overall maximum value it can read how much? 3 volt. And this 3 volt is divided into how many major grids? 1, 2, 3 and 4. So I can say that the reading from 0 to this first grid, this overall reading is how much? 3 upon 4, because the over 3 volt is divided into 4 small major segments. So each major segment is equal to how much? 3 by 4, that is equal to 0.75 volt. But 0.75 volt is not the least count. Why? Because further this 0.75 volt is also divided into how many? 5 small divisions. 1, 2, 3, 4 and 5 small divisions. So I am interested in this particular value. So this particular value will be given by how much? When we divide 0.5 with 5, then we are getting this least count 0.1 volt. 0.15 volt, and 0.15 volt is available in option A and C. Therefore option B and D are eliminated, right? Because this and this, that is not matching with the least count. The value of least count is 0.15 volt. Now the second thing we have to find out, how much is this value. So we know that till this point it is kitna? 1.5 volt. So now, how many after that minor grids are there? 2. So each length is equal to how much? 0.5. So the voltage recorded by needle is how much? 1.5 plus how many small divisions? 2. The value of each division is 0.15. So 1.5 plus 0.3, we are getting 1.8 volt. So right now the needle is showing how much? 0.8 volt. So answer is what? C. So this is the question, how to deal with the least count and the value of the particular reading. So same question can be asked for ammeter also. So in the same manner you have to do for the ammeter. The reason is that in ammeter the reading will be in terms of ampere. Here the readings are in terms of volt. Sometimes they may provide reading in terms of the millivolts also, right, or milliampere. So according to that you can answer the question by checking the proper reading. Now, extra point about this. So we know that we use two apparatus or two instruments very frequently in our circuits. One is voltmeter and the second we use as ammeter. Now let's have little discussion about voltmeter and ammeter. Voltmeter we use to record the voltage. Ammeter we use to record the current. How we connect voltmeter? We connect voltmeter in parallel. We connect ammeter in series. Another thing, why we connect voltmeter in parallel, sometimes this question can be asked. The reason is that the resistance of voltmeter is very, very high. Right, resistance of voltmeter is very, very high. Therefore, negligible amount of current will flow through the voltmeter. Most of the current will go to the main circuit. And ammeter, the resistance of ammeter is opposite. The resistance of ammeter is very, very, very low. So it do not consume any potential difference. That's why we connect it in the series and it is used to record the value of the current. So these are the few important points that you should know about how we place them in the circuit. And sometimes they ask about the reason also why place in parallel and why place in series. So hope you can tackle now the problems based upon the instruments, any problem if you are getting in the exam. So now the next problem we are having is so now the next question, that is from again CBSE 2024, 1 mark question. This question looks very simple, right? If you see that directly, you can directly say that it is in series combination and directly answer will be 2 plus 5, 5 plus 6, kitna? 11. But unfortunately 11 is not the option, right? But if you see that, luckily 11 is not the option. If 11 is the option, then most of the students will commit the mistake in this question. It look like series, but it is not series because you can see here in between wires are connected. We cannot say that directly it is in series combination. So it's a tricky question and the question was asked in 2024. It was 1 mark question. So let's see how to solve this question. Before solving this question, we need to keep one thing in mind, right? Generally in circuit, the wires which we use, they are the good conductor. And in good conductor, generally what happens, when we connect any wire through a battery, right, the potential drop generally come out to be approximately 0. So we can assume that the potential of the wire will be same throughout. If let's say this end potential is A, then at every point the potential will be A only. And if the negative terminal at let's say B potential, then the potential at every point which is connected to this negative terminal will be B only. Means potential will remain same because the resistance of wire is very low. So therefore there will be no loss of the potential across the wires. That concept we have to use there in this question. Now how to tackle this problem? Let's see. Now I'm assuming the battery is connected over there. I'm assuming that this end is having at, obviously positive means high potential, negative means low potential. I'm assuming this end is at A potential, this end is at B potential. Now what does it mean? If the wire is connected, that everywhere potential is how much? A. So at this point also potential is how much? A. Now the wire is connected from this point to this point, the potential will be again A. So this point will also having potential A. Now the second end is connected where? Here. The potential at the negative end is B and obviously B is less than A. So throughout the wire the potential will be B and here also the potential will be B. And further the wire is connected over there, the potential is also at B. Now how to make the circuit? One end I am taking at potential A. Another end I am taking at potential B. Means what? These are the wire which are connected to our required battery. That is one end is at A, another end is at B, and potential difference is kitna? A minus B. Now I know that between A and B, which resistor is connected between A and B? First of all, 2 ohm resistor. So I'll place this 2 ohm resistor which is connected between A and B. Now second, 3 ohm resistor is connected between B and A. B and A means A and B. So I can place this resistor 3 ohm over there. That is also between A and B. Now 6 ohm resistor, that is also connected between A and B. The 6 ohm resistor we have connected again between A and B. The circuit which look like series, actually it is what? Parallel circuit. And we know that in parallel circuit, I can find out the overall resistance is 1 by Rp is equal to 1 by R1, 1 by 2 plus 1 by 3 plus 1 by 6. When you will solve, you will get 6 as the LCM, and here you will get 3 plus 2 plus 1. So overall 6 by 6, how much? 1 ohm. So the right answer we are having is 1 ohm. So when you have such kind of circuit where wires are connected directly from one point to another point, look that circuit carefully, observe that circuit carefully, and then answer the question. Don't directly just seeing that and write the answer. This is a very good problem that was asked in 2024. You should look this question again. Pause this question and try this question by yourself also. So this is the question number 5. That is how you have to tackle such problems. Next problem we are having is next question number 6, that now we are taking, that is a 2-mark problem. So 1-mark problem that we have discussed, we try to cover most of the important topics. Now the 2-mark problem we are having, this problem now we are having from the resistance and resistivity kind of relation that we are having. Question says that 2 wires A and B of same material. Now material is same, what you should what it indicates means the resistivity of one material is equal to resistivity of the second wire. Means we are having 2 wires A and B. So means what? Resistivity of A is equal to resistivity of B. Second thing, having same length. Now see, another information. L1 is equal to L2. I am assuming 1 and 2 for A and B. You can use A and B also, right? So in this case, read question very carefully and draw the data when you're reading the problems. So here we draw the 2 important points. That is, one, resistivity is equal because material is same. Second, length of the wire is equal. So that also we have conclude the result. And after that, they are saying diameter of the wire is 0.2 and 0.3 mm. Diameters are not equal. So the diameters are not equal means what? We have to write now the data. So here I am writing the data for both the wires individually, and based upon this we'll calculate. Now after that, are connected one by one. They are connecting them one by one. First they are connecting wire A, then they are connecting wire B to the circuit. Which one of these 2 wire will offer more resistance to the flow of the current in the circuit? And justify your answer, right? We have to justify after finding the answer also. So we have to calculate ultimately what? Resistance. So I am writing here wire A. This side I am having wire B. Now the what data is given? Now the given data for wire A is what? Resistivity of wire A, and that is equal to what? Resistivity of wire B. Next it is given length of wire A, that is equal to what? Length of wire B. But diameter of wire A is not equal to diameter of wire B. So diameter of wire is how much? 0.2 mm. Keep one thing in your mind, that 0.2 mm unit is in millimeters, right? So similarly, diameter of wire B is how much? 0.3 millimeters. Now we know that from this data, I can say that diameter of wire B is greater than diameter of wire A. And if diameter is more, then we know that area, cross-sectional area of wire A, cross-sectional area of wire A is equal to kitna? Pi r square, or we can say pi by 4 dA square. Can I say area is directly proportional to diameter square? From this expression, we can say area is directly proportional to diameter square. Means more the diameter, more will be the cross-sectional area. So using the same logic, because we don't have, the values are not given. Resistivity actual value is not given. Length actual value is not given. So we cannot find the absolute value of the resistance. So here, the hint is that we have to compare the value of resistance of both the wires. So in this question, you can see that the diameter of wire B is greater than diameter of A. So can I say from there cross-sectional area of wire B is greater than cross-sectional area of wire A? Now if we know this relation, then we also know that resistance of any wire is equal to resistivity into length upon cross-sectional area of the wire. This formula we have to apply there. Resistance of any wire or any material or any conductor is equal to resistivity of that material into length of that material divided cross-sectional area of that particular component or resistor or wire. So here can I say for both the materials, either we can directly write resistance inversely proportional to area, or else we can also use the concept of ratio here also. We can calculate now the ratio of both the wires, the resistance of the wires. So if I calculate the ratio of the resistance of both the wires, so what I'll get from there? I'll get resistance R1 or resistance of wire A divided resistance of wire B is equal to resistivity of wire A, length of wire A divided cross section of area of wire A, and you know that when we'll take the ratio, multiply by area cross sectional area of wire B divided resistivity of wire B into length of wire B. And we know that resistivity and length both are same, so the product will also be same. So we can cancel this out. So this will get cancelled, right? This will cancel with this. So we are finally left with what? Area of wire B divided by area of wire A, and we know that area of wire B is greater than area of wire A. So therefore this ratio will be greater than 1. So I can say that RA upon RB will be greater than 1. Why? Because area of B wire is greater than area of A wire, because diameter of B wire is more. And from there what I can conclude? Resistance of wire A is greater than resistance of wire B. So finally what we got to know? The resistance offered by wire A will be greater than resistance offered by the wire B. So that is our final answer. And how to justify your answer? Because we can tell that resistance is inversely proportional to cross-sectional area. And if the diameter of wire is less, then the cross-sectional area will also be less. And if cross-sectional area will be less, that means resistance will be higher. So we can explain or we can justify our answer according to this reasoning. So this is how we can tackle the problem, and this is how we can do the calculation. So in this part we have not calculated the exact absolute values because data is not provided. So that's why we are doing the comparative study between two wires. So this is how you have to tackle this question. Now the next problem we are having. Next question is, that is from 2023, and the question now based upon the graphical questions. Now based upon graph, Ohm's law graph, we get questions in MCQs also, we get questions in our 2 mark, 3 mark, 4 marks also. In 4 mark also you can get this question, right, where they can bifurcate the question into 3 different parts. So now let's focus on this question and we'll try some extra points also in that. Question number, this says that a VI graph for 2 conducting wires. Now when you read the question, try to draw or try to write the data also. Now the 2 conducting wire A and B. Now we are having 2 wires A and B, and these wire A and B are as shown if both the wires having the same length. Now again the question is what? LA equal to LB, same length. Next, same diameter also. Now DA equal to DB, and if diameter is same, so can I say cross-sectional area of A equal to cross-sectional area of B also? Means area, cross-sectional area, right? If this is the wire, then we are talking about this area, not the complete area. In this we take care of only cross-sectional area from where current is entering, from where electrons are entering. We are not taking care of the surface area, right? That's why pi r square or pi by 4 d square we consider in this case. So diameters are also equal. Now in this case we have studied which of the 2 wires, which of the 2 is made up of material of high resistivity. Now the question is what? You have to predict now the resistivity, whose resistivity will be higher, and for that information is given in terms of graph. Now see, if the resistivity will also be equal, then obviously resistance will also be equal, and if the resistance will also be equal, means both the graphs should be coinciding graphs, but the graphs are having different slope, means they are making different angle with the x-axis. That means they are having different slope. Different slope means they are having different resistance, and if they are having different resistance, that means they should have different resistivity. Why? Because length and diameter of both the wires are same. So again we have to use which formula here? We have to use the formula that is resistance of any conductor is equal to resistivity into length of the conductor divided by cross-sectional area of the conductor. Again we can use the concept of ratios, that is R1 by R2, right? Or directly we can say resistivity, we can say that from there, the length of the conductor, which is already given in the question, that the length of the conductor is equal, cross-sectional area is equal, length and areas are equal for both the wires. Now we can say resistance is totally dependent upon what? Resistivity. And how it is dependent? Resistance of material is proportional, directly proportional to resistivity. So if direct relation is there, then we can say that the ratio of resistance R1 by R2 can be written as rho 1 by rho 2, means resistivity of 1 by resistivity of 2. Now question comes, how we can get now the answer from there. So let's check what is the value of actual value of the resistance, right? So for that, how to check? Well, so there is a shortcut, right? Whatever graph is closer to the voltage axis will be having the high resistance value. But if we talk about logically, so it is up to you. We know that voltage is equal to current into resistance. Voltage is equal to current into resistance. That is a formula according to Ohm's law. Now you can select any random value of the current, any random value. We don't know this value, what is that value, but we know that if I have to pass, this value of current, I am taking, let's say, 1 ampere of current, if I have to pass from both the wire A and B, where I need to apply more potential difference. And we know that higher the resistance, higher will be the potential difference is the required, or low the resistance, less potential difference is required to pass the same value of current. That's why I taken current I value constant for both the resistors, right? So I am having resistance that is R1, and this is another resistance I am having R2, and I want to pass in both the resistors same value of current. And how to read from the graph? If I am passing I value of the current, then the voltage required for this conductor A will be corresponding to voltage axis, this is VA. Now for the same value of current, the voltage required from for the resistor B is BV, and we know that from the graph that VV is greater than VA. Means what? For the same current, if you need more voltage in resistor B, that means I can say from there resistance B is greater than resistance A. And if we know resistance B is greater than resistance A, so from there I can say resistance B divided resistance A will be greater than 1. And if the ratio B by A is greater than 1, so now I can use this relation over here. Here I am using R1, R2, so we can make it as a RA, RB. So that is equal to what? RA upon rho B. And we know that RB by RA is greater than 1. So can I say the same statement, or RA upon RB will be less than 1? Right? We know phi is greater than 1, but 1 by phi is less than 1. So less than 1. And we know that RA upon RB is less than 1. So from this relation, what I can say? Resistivity of wire A upon resistivity of wire is less than 1. So this implies what I can say? Resistivity of wire A is less than resistivity of wire B. So we conclude from there that the resistivity of wire A is less compared to resistivity of wire B. So I think this is the question. So give the reason to justify your answer. So these are the reasoning we have provided. So you can use these relations and you can answer the question. So this is the one way to solve this problem. And in the similar manner, this question generally asked in MCQs also, where they will provide you the graph and they will provide you different graphs, A, B, C, 3 resistors they will provide you, and they will ask you arrange them in increasing or decreasing order of their resistances, right? So these kind of, or arrange them in increasing order and decreasing order of their resistivity also. So by using the same logic, you can tackle those problems. But if it is for MCQ, then you are not supposed to do this whole complete calculation. For MCQ, you can use the direct method of this. Take on x-axis any point means current, and then simply draw one perpendicular line and check the corresponding values in the voltage axis. If the potential difference is higher, means that particular resistance or the graph corresponding to that particular resistor will be having high resistance. So that concept we can use in this particular question. Now, there's another way to tackle this problem. So that also we can use. Instead of taking now the current same, you can take voltage also constant. Let's say you're applying 10 volt across both the resistor. Now you have to check that, right, 10 volt across both the resistors. Now you can check here. Let's say I'm applying 10 volt across both the resistors. Now you can check for that voltage in which resistor the flow of current will be more. So less the resistance, more will be the current flow. So you can see here for conductor B, the current flow will be, let's say, IB, and for conductor A, current flow will be IA. So from there also for MCQs, we can also write answer. For this question also, you can use this logic also, that if you set the voltage, fixed voltage across both the resistor, the flow of current will be more in A resistor, that means resistance of A will be low. And if the resistance of A will be low, that means resistivity of A will also be less. So according to that, we can tackle such graphical problems. So this way. Okay, so the next question we are having is question number 8, that is from CBSE 2024 3-mark question. Now it is based upon the circuit diagram. We have to make the circuit diagram, and when we are making the circuit diagram, we have to take care of the fundamentals of the circuit diagram. Question, draw the schematic diagram of the circuit consisting of one battery, and battery is having how many dry cells? 4 dry cells, and each having voltage of 1.5. So means total overall voltage we are supplying is how much? 1.5 into 4, 6 volt. And connecting 2 ohm resistor, 6 and 16 ohm resistor, one plug key, and all connected in series. Put an ammeter to measure the current and voltmeter across 16 ohm resistor, and to measure the potential difference. Using Ohm's law, determine the value of the ammeter reading and voltmeter reading when key is closed. Now when you're closing the key, means circuit is closed, and we have to find out how much current is flowing through the circuit, that is recorded by the ammeter, and what is the potential difference across 16 ohm resistor, that will be recorded by the voltmeter, because voltmeter we are connecting across 16 ohm resistor. Now let's start drawing the circuit diagram. So we are having first of all 4 1.5. So this is the cell is represented by positive and negative terminal, but it is a combination of 4 cells. So you have to represent 4 cell combination. One side is positive, another side is negative, and each is 1.5. So total we are using how many? 4. Overall voltage of the battery is 6 volt, and along with that we are connecting what? We are connecting a battery of the 4 will be connected to the resistor. So this is our first resistance, second resistance, and third resistance, each having values how much? 2 ohm, 6 ohm, and 16 ohm resistance. And after that we have to connect what? A plug key to connect all in series, and one ammeter also. So here I am connecting one ammeter, that is positive, negative, and also along with that we have to connect voltmeter, but voltmeter we have to connect where? Across 16 ohm resistor. So this is the 16 ohm resistor, this is the point A, and this is the point B. We are connecting one voltmeter across this 16 ohm resistor, and after that the ammeter is connected to the battery, and along with that we are using what? One plug key. So right now plug key is open, so current is not flowing, but when you close this plug key, now circuit is closed and current will start flowing through all the throughout the circuit, and this is how the current will enter from one side and leaving from the another side. So this is the circuit diagram that is required. Now the second part of the question is using the Ohm's law, we have to determine the ammeter reading. Now we know overall voltage. Now we have to calculate the ammeter reading. So whatever current is flowing through the ammeter, means that current is flowing through each resistor. So to calculate the resistance, overall current flowing through the circuit, we need to calculate what? Overall resistance of the circuit. So for that we have to use what? Equivalent resistance. And equivalent resistance, how to calculate? In series we know that equivalent resistance is what? The sum of all resistances, and that is connected to what? That is connected to a battery of 6 volt, and overall resistance how much? 2 plus 6 plus 16, that you have to write RS is equal to first R1 plus R2 plus R3, and after taking the sum we are getting the value how much? 24 ohm. Now we got the value of 24 ohm, but I am interested in calculating the value of current, and according to Ohm's law, V equals to IR. Voltage is given, overall resistance we have calculated, that is RS. So RS value is how much? 24. So overall current will be equal to what? Overall voltage divided by overall resistance of the circuit, that is V upon RS. So V value is given how much? 6 divided RS is how much? 24. So when you solve, you will get 1 by 4. 1 by 4 means I is equal to 0.25 ampere. What does it mean? It means that the 0.25 ampere will flow through each resistor, and the same current will be recorded by ammeter, that is 0.25 ampere. So this is the reading of ammeter. So first part is done. Second part, what is the reading of the voltmeter? So to calculate the reading of the voltmeter, we need to do what? We need to apply the Ohm's law. Again we have to apply Ohm's law across resistor number resistor number 3, that is R3 16 ohm. So can I say from there R3 is equal to 16 ohm. Current flowing through third resistor is same as drawn by the circuit where circuit is in series, and we know that according to Ohm's law, the voltage across third resistor is equal to current flowing through third resistor into resistance of the third resistor, and that is equal to how much? 16 into 0.25. 0.25 means 1 by 4, and 16 by 4, the voltage developed across the kitna? 4 volt. So 4 volt is the voltage across V3. So 4 volt out of 6, 4 volt is consumed where? At V3. So with this our problem is done. But if they ask about other also, you can calculate other also. In 6 ohm, current is flowing how much? 0.25 ampere. What is the resistance? 6. So 6 into 0.25, 6 by 4. 6 by 4 means 1.5. So voltage across second resistor will be 1.5 volt. Voltage across obviously first resistor will be kitna? 6 minus the sum of other voltages. 4 plus 1. 5.5 and 6 minus 5.5 is kitna? 0.5 volt. Although they have not asked this, but if they ask, you can write these voltages also by using Ohm's law. And we know that in series, overall voltage, the total voltage is equal to sum of each voltage, V1 plus V2 plus V3 equal to 6 volt. And we know 0.5 plus 1.5, 2, and 2 plus 4 is how much? 6. That is the one conclusion that we can draw. Another conclusion, we always say that when the resistance of path is higher, the current flow will be less. Or if you have to pass the same amount of the current, you need to apply large potential difference. So you can see that higher the resistance, more will be the potential difference required. And low the resistance, less potential difference will be required. But this rearrangement of potential difference will be in such a manner that overall voltage will be equal to the total voltage supplied across the whole circuit. So I hope you can tackle these problems in this manner. Now the next problem we are having is, so again that is a question from Ohm's law. Now it's not a theoretical kind of question, one part, that is a state Ohm's law. So it's a theoretical question, but when you're stating the Ohm's law, you have to state it properly. You have to take care of all the conditions that are there for the Ohm's law. The first condition is what? That the Ohm's law states that whenever the current is passing through a conductor, or we can say that according to Ohm's law, the current flowing through the conductor is directly proportional to the potential difference applied across the conductor by keeping its temperature constant. We should not allow the temperature of the conductor to increase or decrease, because the resistance of the conductor depends upon what? It depends upon the temperature of the conductor. That's why maintaining constant difference is important point. You should mention in the definition of the statement of the Ohm's law that the current flowing through a current carrying conductor is directly proportional to the potential difference applied across the conductor by maintaining its constant temperature. And from there we got mathematical expression of Ohm's law, that is V equals to IR. That is V is proportional to R, means when you remove the proportionality constant, we introduce the proportionality constant, that is R. And R is what? R is the resistance of the conductor, and that is equal to V by I. So when you increase the potential difference, current will also change, but the change will not be a random. It will change in such a manner, the ratio V and I will be remain same, that is equal to R. And this R is a constant ratio, and that is called as a resistance of the given conductor. Now second part of the question is, list two factors on which the resistance of a cylindrical conductor at a given temperature, see, at a given temperature, mean temperature is constant, depends. So we have studied that resistance of any, let's say this is a cylindrical conductor having length L, diameter D, and obviously it is having some material, so its resistivity will be rho. So resistance of any conductor, any material, depends upon, one is the material property. The material property is taken care by rho. That is a material dependent property, and that do not depends upon the dimension. And the second factor on which resistance depends, that is, one is length and second is area of the cross section. So you can say that the two factor on which resistance of the wire depends is, number one is directly proportional to L, means if you increase the length of the conductor, resistance will increase. And the second point is inversely proportional to cross-sectional area, or is inversely proportional to diameter square, or is inversely proportional to radius square. All are the same things, right? So inversely proportional to cross-sectional area. More the cross-sectional area, less the resistance. Less cross-sectional area, more the resistance. In other words, thin the wire, more the resistance. Thick the wire, less the resistance. So these are the two factors on which resistance of the conductor depends. Next part of the question. Now, the next part of the question is, a wire was drawn into a wire is drawn into a wire of double its length by melting. So what we did, original wire having length L, now we melt this wire and we increase its length to 2L by melting. If the resistance of old wire is how much? R. Old wire resistance is resistance R, then what is the resistance of the new wire? So now how to tackle this second part of the question? Now what they are saying, now the second part of the question says that you are having two wires. So this is the wire number 1. The wire 1 having length L and cross sectional area, let's say A, and resistivity is rho. Now what we are doing after that, we are melting it. So after melting, what we are doing, we are changing the diameter of the wire. The diameter of the wire means what? Obviously diameter of wire is going to change. Why the diameter of wire is going to change? Let's discuss that. By melting, we increase the length of the wire to what? We made it 2L. But by melting, material of wire will remain same, so resistivity will remain same. But we know that if we are melting the wire, so here we are taking one assumption, the volume of the wire is not going to change. And volume of the wire, that is V1 is equal to V2. And volume of wire is the length of the wire into cross-sectional area of the wire is equal to length of the second wire into cross-sectional area of the second wire. So from there, length is what? Twice. We know that L2 is equal to 2 times of L1. So therefore, if you solve, so from there what you will get? Area of the second wire will be equal to what? Half the area of the first wire. Obviously, if length is increasing, then wire become thin. The cross-sectional area become what? Half. Is that clear? The cross-sectional area of the wire become half. Now we have to calculate the resistance. So now we know that R1 by R2 is equal to rho 1 L1 upon rho 2 L2 multiply by A2 upon A1. Now we have to take resistivity of the wire is same. The resistivity is going to cancel with the resistivity, and L1 by L2. We know that L1 by L2. L2 is double of that. So L1 by L2 ka ratio is what? L1 by L2 is 1 by 2 multiply A2 by A1. A2 by A1 is also kitna? 1 by 2. If A2 is equal to A1 by 2, so A2 by A1 is also 1 by 2. Area become half, length become double. So finally we are getting what? 1 by 4. So that ratio is what? R1 by R2. But we are interested in what? We are interested in R2 value. So this implies R2 is what? 4 times of R1. So I can say that resistance of the second wire is equal to 4 times of R. Why? Because R1 value is given in question, that is equal to how much? R. The resistance of the second wire become 4 times of the resistance of the first wire. So that is the second part of the problem. That is how we can solve. And also we know that as we know that the length is increasing, so length is increasing, resistance will increase, and also with increase in length, area is decreasing. So if the denominator is decreasing, then further resistance will also increase. So overall resistance will increase, and that become 4 times of R1. Right. So also sometimes they ask about percentage change. The percentage change will be kitna? 300%, because 4R minus R by original resistance R, that comes out to be 300%. That question comes in MCQs. So this is how we have to tackle the these kind of problems. So now the next problem we are having is question number 10. So next question is question number 10. Now this question is based upon the hybrid circuit. Now you can see these 3 resistors are in series, these 2 are in parallel, and this combination is further in series. So this we can say as a hybrid combination. 2023 4-mark question. So the circuit is given. On the basis of circuit, we have to find out number 1. The first thing we have to find out in the question is find the value of the total resistance between point A and B. See, this question is divided into so many 2-3 parts in such a manner that we can proceed in step by step. So what is A and B? A and B means what? In A and B, we are having only 3 resistors which are in series. So you need to tell that, give the name that R1, R2, R3, and this is what R4 and R5. So here what I can say from there that R1, R2 and R3 are in series between A and B. So therefore the equivalent resistance between A and B, I'm writing it as RAB, is equal to sum of R1 plus R2 plus R3. And when you will substitute the values, what you will get? 16 plus 6, 22 plus 4, 26. So we are getting how much? Resistance between RAB, equivalent resistance, that is equal to how much? 26 ohms. If you substitute the value, you will get this answer, 26 ohm. Now the second part of the question is, A part is done, B part of the question is, find the resistance between the point B and C now. Where is point B? This is point B and this is point C. And in between B and C, we are having two resistors which are connected in parallel. So now we can say that R4 and R5 are connected in parallel combination, between B and C. So therefore, RBC is what? Resistance between B and C. And we know that when two resistors connected in parallel, I can directly write that as the product of two resistors. What two resistors are there? R4 into R5 divided by sum of resistance R4 plus R5. So what value we are getting? And another alternate method of doing that question is that since both the resistors are equal, so resistance of each resistor divided total number of resistors, from that also we can calculate. So we got answer is 8 into 8 divided by 16, and 8 8 is 64 by 16 is 4. So we are getting RBC, which is equal to how much? 4 ohm. So the second part of the question is also done. That is the resistance between B and C, we got how much? 4 ohm. Now let's see the third part of the question. So now to understand the third part of the question, is calculate the current drawn from the battery when key is closed. Now we are saying that calculate the current drawn by the battery when the key is closed. So let's go back to the previous slide. So in this case, the battery is now, circuit is now closed. And when the key is closed, that means circuit is closed now and the current will start flowing from this battery. Let the I current is flowing. And we know that this equivalent resistance of this we are getting is what? RAB, which is we calculated 26 ohm, which is further connected in series with RBC, which is how much? 4 ohm. And this whole circuit is connected to the battery, and this battery is having potential difference of 6 volt. Now we know that RA and RB are series, so R equivalent of the circuit is what? RAB plus RBC, and that come out to be 6 plus 24 is how much? 30. 26 plus 4 is 30 ohm. And how much voltage is applied? 6. Now I'm applying Ohm's law. So V equivalent is equal to R equivalent multiplied by current flowing through the circuit. Whatever current flowing through the circuit, I is equal to V by R equivalent. And V is how much? 6. R is how much? 30. So we are getting 1 by 5, and that is what? 0.2 ampere. So means how much current is flowing from there? 0.2 ampere current is flowing from the circuit. So that is the third part of the question, that the circuit will draw how much current? 0.2 ampere current will be drawn by the circuit. So now we are having question number 10, last C part, in C OR part. So in OR part we have to calculate in the above circuit the 16 ohm resistor or the parallel combination of the two resistors of 8 ohm, which one of the two will have more potential difference across two ends. Justify your answer. So we need to check now, in this case, the 16 ohm resistor and the combination of these two 8 ohm resistor, in which case we are having more potential difference, that we have to find out. So what we are doing here, so we are using one voltmeter and connecting one voltmeter across 16 ohm, as well as we are connecting another voltmeter that is representing V2 value corresponding to parallel combination of 8 ohm. So in the first question, third part, we have calculated how much current is flowing through the circuit is 0.2 ampere current is flowing through the circuit. Means 0.2 ampere current will flow through each resistor, because A to B they are having series combination. And if I apply Ohm's law in 16 ohm resistor, so I can say that 16 ohm resistor, so this is R3, so V3 is equal to R3 into I3. I am interested in calculating V3. So resistance is 16 ohm multiplied by current flowing through the circuit is 0.2 ampere. So the value come out to be 16 into this is 3.2 volt. So the voltage across 16 ohm resistor, that is how much? This voltage is V3 and that is equal to 3.2 volt. And now the voltage across this parallel combination, let it be Vp. So Vp will be equal to what? So Vp is equal to the current through parallel combination multiplied by overall resistance of the parallel combination. We have just calculated there the overall resistance of parallel combination is 4 ohm and the current will flow. The same current will enter and leave through the circuit, that is 0.2 ampere, multiply by resistance of the circuit is 4 ohm. So we are getting from there 0.8 volt. That is the potential difference across the parallel combination. So from there we can find out. So from there we can find out. Sorry, this is when you solve it. So we will get yes, 0.8. Correct. This is 0.8 volt potential difference is generating across this one. So from these two values we can easily say that the potential difference across 16 ohm resistor will be more compared to the parallel combination. So this is the answer for the OR part of the 10th question. The potential difference across 16 ohm resistor will be more and the values are as. Next is question number 11, that is from 2024, 5-mark problem. Now in this question, let's write the relation between resistance and electrical resistivity of the material of the conductor in the shape of cylinder of length R and area of cross section A, and hence derive the SI unit of electrical resistivity also. Now let's say the wire given is what? Cylindrical wire, and length of the wire is given L, cross section of the wire is given A, and resistivity of the material of wire is given as rho. Now we have to find out the relation, and we know that the relation is what? Resistance is directly proportional to resistivity, length of the conductor, area of the conductor. So rho L by A, that is the relation between the resistance and resistivity of the material. Now the question is, find the SI unit of the electrical resistivity. So let's put the SI unit of different the variables or the fundamental quantities. So the resistance unit is what? Ohm. So from there I can say rho is equal to R into A by L. So resistance unit is ohm, area ka SI unit is meter square, divided length unit is meter. So meter and meter square will cancel. So the unit of resistivity is ohm meter. That is the SI unit of resistivity, that is ohm meter. So this is how we can derive the unit, and it is not restricted only up to this particular problem. Wherever you asked about the units, so whatever parameter unit you are supposed to ask, keep it on one side, and all other parameter by using mathematical operations bring to another side, then substitute their units, SI units, if it is asked in SI unit, or if it is asked in other CGS unit, then you can put the CGS units also, and then finally simplify your the expression, and you'll get the final unit of that physical quantity. So now the second part of the question, first part is done. Second part of the question is that if the resistance of the wire is of length 3 meter, resistance is 60 ohm, cross-sectional area is also given 4 into 10 to power minus 7 meter square. Calculate the electrical resistivity of the material. So for that we will apply this formula, electrical resistivity RA by L. So let's see how to solve this particular problem. So I am interested in calculating the resistivity. So I know that R is equal to rho L by A. I am interested in resistivity. So resistivity will be equal to resistance into cross-sectional area divided length. So resistance is 60 ohm, multiply by cross-sectional area is 4 into 10 to power minus 7, divided by length is how much? 3. So it will get cancelled with 20. 20 into 4 is how much? 80 into 10 to power minus 7. Unit is very important. You should write units also. Unit of resistivity we just calculated, ohm meter. So that is the value of resistivity of the wire, 80 into 10 to power minus 7, or you can write it as 8 into 10 to power minus 6 ohm meter. Any of the answer is correct, right? So second part is also done. In that we have to solve this numerical. Third part, state how would electrical resistivity be affected. Now in the question they are saying that how would the electrical resistivity of the conductor will be affected if the wire of part 2, means the part 2 wire, is stretched so that its length become double. Now what we are doing, the length initially was L, and after stretching we are making its length 2L. Right, so justify your answer also. In this case, they have not mentioned anything about the volume of the wire. So in this case, we are going to assume, you should write, the assumption is by stretching volume of the wire remain constant. And if the volume of the wire will remain constant, that means L1 is equal to L and L2 become 2 times of L. But area of first wire will be A and area of the second wire will also decrease, right? And that become how much? A by 2. So when the length is increasing but area is decreasing, so in that case what will happen? Overall expression, length is increasing, area is decreasing. So in this case, if you solve, what you will get, resistivity of first wire will be equal to resistivity of the second wire. By solving it, we are getting rho 1 will be equal to rho 2. Why? Because it is not a dimension dependent property. As I told you, resistivity is a material property. So when you're stretching, compressing, so in that case, material of the wire is not going to change. And if the material of wire is not going to change, the resistivity will remain same. So don't write, and even if you solve mathematically also, you will get the same answer. The resistivity of the first wire will remain same because resistivity is a material property. It's a dimension independent property which does not depend upon the length, cross-sectional area, diameter and all. So this is how you have to tackle. This is a very important question. This question generally asked in the MCQs also by framing a huge statement, but you have to look for whether they are asking about the ratio of the resistivity or resistance. Resistance definitely will change, but resistivity will not change. That will remain same. So this is the next question. So the next question we are having is, that is question number 12 from 2023 5-mark question. It is based upon now the commercial unit of energy, means the electricity bill which we are getting at home. So what is that unit we are using? That is the commercial unit of the energy. So the question is, what the commercial unit of electrical energy is commonly known as unit. So the common name is what? Unit. So, and write its actual name. Actual name, what is the scientific name? You can say that actual name, and establish the relationship between this unit and SI unit. So actual name is what? The commercial unit, which is also known as unit, and this commercial unit means 1 unit or 1 commercial unit is equal to 1 kilowatt hour. So that is the actual name of unit, that is 1 kilowatt hour. And now we have to establish the relationship between the unit and SI unit of the energy. So this is what? Energy, right? So and we know that if we know the formula of power, so power is equal to what? Rate of energy consumption or rate of energy production. So energy upon energy consumed divided by appliance divided by time for which that appliance is operated. If you cross multiply, then we can calculate energy consumed by any appliance is equal to power of the appliance multiplied by time for which that appliance is operated. So by the product of power and time, we can calculate the energy. Now we are interested in which unit of energy? Kilowatt, right? So I know that 1 kilowatt hour, that is also the unit of energy. 1 kilowatt hour can be written as what? Power. When I use 1 watt, when I use 1 kilowatt appliance, when we are using 1 kilowatt appliance for 1 hour, then the energy consumed by that appliance will be 1 kilowatt hour. But we are now interested in what? We are interested in the SI unit. So we want the relationship between this commercial unit and SI unit. So let's put the values. I know 1 kilowatt hour means what? Appliance of 1 kilowatt is running for 1 hour. That gives the 1 kilowatt. And 1 kilowatt can also be written as what? 1000 watts. The unit of power, SI unit of power is what? Watt. But the watt is very small unit. That's why we use bigger units. 1000 watt multiply 1 hour equal to, now I want relation between this and SI unit. The unit of SI unit of time is what? Second. And 1 hour, we know that 1 hour equal to how many seconds? 3600 second, means 60 minutes into 60 seconds, 3600 seconds. So multiply by 36. So we are getting how much? 36 into 10 to power 5 what? Watt second. And watt second is nothing but watt second itself, we call it as joule. So that can be written as 36 into 10 to power 5 joule, or we can write as 3.6 into 10 to power 6 joule, or we can say 3.6 megajoule, right? So all these are the relationship between the kilowatt and the other units of energy, but we are interested in which form of the energy unit, SI unit. So our answer will be 1 kilowatt or will be equal to 3.6 into 10 to power 6 joules, because joule is the SI unit of the energy. So this is our final relation that is for this part of the question. Now B part is the current rating of the circuit is 1 ampere. Means we are having circuit and the rating of that circuit, the fuse which we are using, that can draw 1 ampere current safely. Now how many LED lamps of power 8 watt 220 volt can be safely used simultaneously in this circuit? So in this circuit, how many 8 watt LEDs we can use safely? So when we are connecting these LEDs, obviously these LEDs are going to draw the current from the main source or the battery. If this current exceed 1 ohm, then circuit may break down, because that is not the safe limit. The fuse which we are using for the current rating is of 1 ampere. So means the current which is flowing through the circuit should remain 1 ampere. It should not exceed that value. So now how to tackle this problem? So we are assuming, as we are not knowing the exact number of LEDs, so let number of LEDs used in a circuit be N. So the power consumed by all LEDs, power consumed, P is what? Power consumed by all N LEDs, multiply N into power of each LED, let that be P prime. So that is how much? The total power consumed is 8 into N, that is N is the total number of LEDs. Now the circuit is having potential of how much? 220 volt, and this 220 volt is drawing how much current? So power is what? V into I. So overall power consumed is how much? V 220 into 1. So that is how much? 220 watt. So the power consumed is 220 watt by N LEDs. So we will equate these both the power, equation number 1 and equation number 2. So we are getting what? 8N is equal to 220. So N is how much? 220 by 8. And if you solve, you are getting 27.5 LEDs. But you know that LED number cannot be in fraction. So we want to run the circuit for safe. For the safety, we should use less number of LEDs. So the immediate integer number is what? 27. So the number of LED we should apply for the safe application. Keeping safety in mind, it should be 27, not 28. So that is how you have to tackle such problems. Now the next question is, that is a 5-mark question again, based upon the graph, or now the graph is not given, but the table is given, and how to find out the information using this table. So question number 1, calculate the resistance of the aluminum wire of length 1 meter, cross-sectional area 2 millimeter, resistivity of wire is this much. So formula, again we have to apply that same formula, that R is equal to how much? Rho L by A. So resistivity is how much? 2.63 into 10 to power minus 8, multiply length of the wire is 1 meter, divided by the cross-sectional area of the wire is 2 millimeter square. So we have to convert 2 millimeter square. We have to convert 2 millimeter square. We have to convert in this case what? 2 millimeter square first. Because millimeter square is not the SI unit, so we have to convert 2 millimeter square into meter square. And we know that 1 millimeter square is equal to how much? 10 to power minus 3 meter, 10 to power minus 6 meter square. 1 millimeter square is how much? 10 to power minus 6 meter square. So this value we have to use. Now area of the wire will be kitna? 2 into 10 to power minus 6 meter square, because we need to keep the values in SI unit. Now the resistance of the wire will be, resistivity of wire is 2.63 into 10 to power minus 8, multiply length of the wire is 1 meter, divided by 2 into 10 to power minus 6. And here we can cancel now 10 to power minus 6 with 10 to power 8, and 2 will cancel it, it will get 1.315. So the resistance of wire will be 1.315 into 10 to power minus 2 ohm. So that is the resistance of wire, and this value is very small value. So that is the resistance of the wire. Next, from the values given below, plot the graph I versus V, show that the data is in conformity with the Ohm's law. So in the second part of the question, we have to draw the graph now. The table is given, and from table we have to draw the graph, and we have to tell that whether the data values which are given, that is in conformity with the Ohm's law or not. So how to predict this answer? If you are getting a graph after plotting these points, you are getting a straight line, that means the data points are in conformity with the Ohm's law. So for that we have to plot the graph. We are given with the potential difference. So potential difference and current is given. So if you observe little bit these values, if you analyze these values, so you can see that they are in conformity with the Ohm's law. You can check the ratio of this is 12. V by I ka ratio is 12, 12, 12 everywhere. And when the ratio V and I is constant, that means slope of the Vi graph is constant, and slope of Vi graph represent what? Resistance. So resistance of that conductor remain constant. So that also we can write. So in this case, as first we are saying plot a graph. So the graph we need to plot it on a graph paper. So what are the current values we are having? 0.1 ampere, 0.2 ampere, 0.3 ampere, 0.4 ampere. Along x-axis we are taking I, and I we are writing in what? Ampere. You should mention the ampere also. Y-axis we are taking voltage axis, so you should write here voltage along y-axis, and current is along x-axis. So voltage we are measuring in terms of volt, and the voltage values also, if you see, that are in equally divided: 1.2, 2.4 and 3.6, 4.8. Now if you join these values, when the current is 0.1 volt, what is the value of the potential difference across that? 1.2. Similarly, you have to plot these points, and when you plot all the points on a graph paper, so you will get a graph which look like a straight line. And now we can say that if it is a straight line, then we can say that these points are in conformity with the Ohm's law. And also we can calculate one more rho V by I ratio. So V by I ratio will be 12, 12, 12 and 12, and V by I ratio is volt per ampere, that is what? Ohm, because ratio of Vi graph represent what? That is the resistance, or in this case the ratio is also constant. The ratio is constant means slope of the graph is constant. Slope means angle with the positive x-axis in anti-clockwise direction. So that constant slope represent that graph is in conformity with the Ohm's law. So these are the few questions that we have taken from the previous year, but you should not restrict your preparation only up to these questions. There are so many other sources also. You should do that practice from the sources like NCERT. You should read very thoroughly. Each and every line is very important, because you can see that they can frame question from NCERT. They can pick any point and they can frame question from the NCERT. So that's why reading NCERT is very important. You should read NCERT, that is very important. Second thing, exemplar. You should solve exemplar textbook also. Along with that, you should refer the previous year question paper. Sample paper you can take, or you can take PDF from the CBSE website and you can solve those question papers. And after solving these question paper, you should squeeze your timing. If the question paper is for 3 hours, you should do it in a 2 hour 30 minutes or 2 hour 45 minutes, because when you solve these questions under pressure, so you will commit more mistakes, more errors, and then you will realize where you commit these mistakes. So the topic which we have taken few important questions that are repetitive kind of questions also, but beyond that there are certain topics that you should keep an eye, you should revise those. For example, the basic definitions. Sometimes they ask define 1 ohm, define 1 joule of energy, or define as a 1 volt potential difference, or the question based upon the potential difference also sometimes they ask. Sometimes they ask about the question based upon the value of charge. The charge is equal to NE, N into number of electron into charge on 1 electron. So based upon that also you can solve some questions. Questions based upon the relationship between current and charge, I is equal to Q by T. So those topics we have not taken in this short video, but you should look for those questions also, and practice more circuit diagram type of questions, because these are the very popular kind of question and the chances are very high you will get question from the circuit diagram. So you should look for those questions. But some question where you also be little bit aware when you get such question in the exam, like resistivity. We have solved the question, right? Because resistivity is a material property, do not depends upon the dimension of the conductor. So such key things where you can commit mistake very easily, you should keep those errors in your mind and you should highlight those errors. You should make your notes for the errors separately, so you should not make the mistake. So this is a short introductory video, or we can say the short informative video based upon our previous year, so that you can enhance your scores. Thank you so much. Stay connected for the remaining videos. We'll come up with some more interesting the content for the betterment of your scores. Thank you so much. We'll see you in the next video.